Okay, I'm trying to hurry through these so you get them when you get home from school. It's already almost 2:30 my time. The fourth one is a really good one. It takes an array of numbers and puts them into a matrix. The directions say make the matrix 2 rows. So the first row, row 0, will have half the numbers, and the second row, row 1, will have the other half the numbers. See how that might look. Let's see, tester 4. So it's called convert. The method is called convert, converting the array called numbers into a matrix of the same values. So we better make a matrix. We don't have one yet to put the numbers into. We got to make one. And so it's going to have 2 rows. The directions say 2 rows. And then how many numbers in each row? That means how many columns do we need? Well, if there's 10 numbers, we need to have 5 columns. If there's 100 numbers, we need to have 50 columns. We need to have what? Numbers divided by 2, numbers.length divided by 2 to be our number of columns. So numbers.length divided by 2. How's that? Okay. And what else? We're going to go through now. There's a couple ways to do this. I'm going to track the position that I'm in the array. So in POS, I'll start off with a 0 position, and then I'll just go through my matrix and put in the value at that position, and then go to the next position, put in the value at that position, and so on. All right, so let's go through this. I'll use R for row. And so what are we doing? We're going to say mat of R C equals numbers of position POS. We've stored that position's value in the matrix. We'll go to the next position, so POS plus plus. And did I not return it yet for you? I was writing the return statement, but I guess I didn't do it in this one. Let's see if this works. Return mat. Any mistakes there? Let's see. Looks good. So we should have 2 rows and a few columns of numbers. And I think that's what they wanted, isn't it? Let's see if that's right. Yeah, 2 rows and 4 columns an example. All right, in number 5, we're doing just about the same thing as number 4, but with a pretty interesting twist. In number 4, we had 2 rows, and they wanted it just like that. 0, 1, 2, 3 in the first row, 4, 5, 6, 7 in the second row. In the second one, they don't want 2 rows, but 2 columns. You can see it better, I think, if I space it like this. And you're putting the numbers in order down the first column and then down the second column. So we go down through column 0, right? You see it happening? We go down through column 0, 0, 1, 2, 3. That's all column 0. So we're not going to go through row 0 and go across. We're going to go down through column 0 first. And this is kind of like doing column major order. So we're going to make 2 columns, not 2 rows first of all. So that just means Put that 2 over there. Okay. And then we go not across the row first with 0, 1, 2, 3, 4, 5, whatever the heck it is, but we go down the column first. Very, very interesting. This is excellent practice for you. Just to see an example of this is really excellent. Okay, that's a big twist. And I think that's all you do, those 2 little changes there. You make not 2 rows, but 2 columns. And you go through the column first. And let's see if that looks right. And there it is, 0, 1, 2, 3 in column 0, 4, 5, 6, 7 in column 1, the second column. Okay, and the sixth and final one here, this is a really weird one. It's only 4 or 5 lines of code, and you can do it probably in a lot more lines of code, but 4 or 5 lines of code is all you need. You're kind of like, you're doing what's called translating. You're translating a two-dimensional array, which just means you're turning it sideways, kind of, sort of. We're taking this row, the 0 row becomes the 0 column. The row 1 becomes column 1. Row 2 becomes column 3. And row 3 becomes column 3. So you see how it kind of turns it around. It's, I don't know, it's translating it. So it's a really tough one the first time doing it. So you got to make a matrix and return it. So I've made my matrix, okay, and the number of columns in the parameter matrix, in the argument there, is how many rows you'll have, and the number of rows is the number of columns you'll have. And I already got this typed in, I'll just do it quickly. This is the last one to get through. So I'm going to loop through the argument and go through its column, go through its columns, and then, of course, the inside loop. If the outside loop goes to the columns, then the inside loop must go through the rows. And then the funniest thing of all is this fourth statement here, probably. Mat of CR, right? So the numbers row corresponds to the new one, the new matrices column. The row of the argument corresponds to the column of the matrix you're building. Vice versa, the column of each of these corresponds to a new row here. And so just return it after that, but that is, 5 very abstract lines of code. You'll probably get it really close to it yourself the first time. You can make a little mistake and have it go sideways or something a little bit different, go out of bounds. But I think if you try this, and me too, I get this wrong all the time. This is a tough one. You can have maybe 12, 1, 20, 0 going down or something. If you just have the wrong thing here, like if you have RC here, then you might go out of bounds. Let's see. Not out of bounds. What happens? Let's see what that looks like. Oh, you do go out of bounds. Yeah, I figured you would for the different sizes. One's got more columns and one's got more rows. So there it is. Tester 6, a really tough one.